Welcome back. We're going to be discussing dienes, dienophile dienes that contain 2 pi bonds. The dienophiles are the ones that have 1 pi bond, okay? So there are 3 types of dienes. There are cumulated dienes, which are directly adjacent to each other. There's conjugated dienes that are separated by 1 sigma bond. And there are isolated dienes, which are separated by 2 sigma bonds. I like to do this. I like to separate each atom and then decide the hybridization of each. This is a carbon, and carbon can form 4 bonds. So it has a hydrogen here, and then each line counts as a bond to this carbon. So you count both lines, okay? So this carbon is sp2. If the carbon didn't have a pi bond, which is this double bond, then it would be sp3. But since it has a pi bond, it's considered sp2. Now onto this carbon. This carbon has 1 single bond and 1 pi bond, and it has 1 additional hydrogen bond, because remember, it forms 4 bonds. And if we were to only count these 2, that would be 3 bonds, because you count each line to that carbon as a bond, even if it's a pi bond. So in this case, this carbon is sp3. Next, we have this carbon. Same applies here. You have a hydrogen bond, because if we don't count that hydrogen bond, we only have 1, 2, and 3. And remember, if it only had 3 bonds and it didn't have that hydrogen bond, that carbon would have a positive charge on it. But since it doesn't have a charge, that tells me that there's an implicit hydrogen atom in there. And so this carbon is also sp2. This is not sp3. This one is sp2, because remember, this has a pi bond over here, okay? So then we have one more atom over here, and this carbon has 2 hydrogens that are implicit, because if we don't count those 2 hydrogens, then we just have 2 bonds. And remember, it does not have a positive charge, so that tells me that there are 2 additional hydrogens bonded to that carbon atom. But if there was a positive charge, then there would have been only 1 hydrogen, because if there's 2 hydrogen missing, it would have been a 2+ charge, and that really does not exist. You would never see something like that in organic chemistry. So with that being said, we're classifying this carbon as sp2 since it does have a pi bond, and the pi bond itself counts as 1 bond, and then it has 2 hydrogen bonds, and those each count separately, so it's sp2. Whenever you see that there are 2 pi bonds that are separated by 1 sigma bond, then just know that those are conjugated, okay? And the same here. Sometimes they draw them very weird, like here, and that gets a lot of people confused. Remember, you still have that 1 sigma bond separating those 2 pi electrons, okay? With that being said, those are the conjugated ones, and then we have the isolated ones. As I said before, isolated are separated with 2 or more sigma bonds, and the way you could tell if there are 2 or more sigma bonds is that if you do the hybridization of each atom, you'll find that there is an sp3 separating these 2 pi bonds. This is an sp3 atom, because if you count the bonds around that carbon, you'll see 1 bond, 2 bonds, 1 implicit hydrogen, another implicit hydrogen, and that's 4 bonds, so sp3. Yeah. So that's for that.